In this video, we're going to reason graphically to determine some limits. So the first one we're going to look at is we have our functions f and g along with their tangent lines on this plot. And we want to compute the limit as x goes to 2 of f of x over g of x. Well, first thing we notice is that f of 2 and g of 2 are both 0. So that makes this a 0 over 0 case and thus eligible for L'Hopital's rule. So that means that this is going to be equal to the limit as x approaches 2 of f prime of x over g prime of x. And now to see if we can solve this one, what we'll want to do is look at the slopes of these lines. So here is f. Notice if we look, we've got a run of 2 and a rise of 1, so it's a slope of 1 over 2. So f prime of 2 looks like it's about 1/2. G prime of 2, g is a bit steeper. We have a rise of, oh actually sorry, that was only a rise of 1/2 for a run of 1, so this so that should be 1/2, excuse me. Right here we have I misspoke, it's a rise of 1/2 for a run of 1. The slope is still 1/2. Right here we have a rise of 2 for a run of 1/2. So 2 over 1/2 or 4, which means this is going to be equal to f prime of 2 over g prime of 2. F prime of 2 is 1/2. G prime of 2 is 4. And so we're going to get that that limit is going to be equal to 1/8. So we're using L'Hopital's rule by looking at the numerator and denominator separately and using their tangent line approximations, or more notably, the slope of their tangent lines. Let's go ahead and look at another one. So we have our functions p and q. They're somewhat quadratic looking. So first off, let's calculate p of 2, q of 2, p prime of 2, and q prime of 2. So p of 2 looks to be about 1.5. Q of 2 also is going to be 1.5. Now we can calculate p prime of 2 and q prime of 2, but we don't need to, because it turns out we know that p of 2 and q of 2 are not both 0. So this is not a L'Hopital's rule, and in fact it can be solved via direct substitution. Now if we did want to calculate these, p prime of 2, here's our line. So let's pick out a couple of points. So it goes down 1 and over 1, so it's got a slope of -1. And we see that q has a horizontal tangent at 2, so it's 0, but we didn't need those because this was not an indeterminate form. In fact, we could solve it via direct substitution. Let's take a look at one more. So r of s over x, s of x. So here's r, this concave up graph. S is this downward opening graph. R of 2 and s of 2 are both 0. So that means we can use L'Hopital's rule and look at the limit as x goes to 2 of r prime of x over s prime of x. Well, notice what's happening there. Both of them are a horizontal tangent at 2. So r prime of 2 and s prime of 2 are also both going to be 0. So this is another 0 over 0 indeterminate form. So in fact, we can actually look at the second derivatives. Limit as x goes to 2 of r double prime of x over s double prime of x. Now we don't have quite enough information to find out r double prime and s double prime, but what we do see is that r double prime of x, well, r is concave up, so that's greater than 0. S double prime of x is concave down, so it's going to be less than 0. So we do know that this limit is going to be a negative value. We would need the graphs of their derivatives, of the derivatives derivative, to get more information on what's going on exactly to calculate it numerically, but we at least know that it's going to be a negative value based on the concavity.